A very good evening to everyone. Am I audible? Thank you so much. We are just waiting for our resource person. We will start the session soon as soon he join the session. A very good evening, sir. A warm welcome and very good evening to all the participants. Resource person of today's session, our respected Dr. Dharmendra Kumar Yadav, sir. Today we are having the last session of this 3-month certificate program on practical session using on SPSS. Now, I would like to introduce again, sir. I hope that all participants will join today's session. Dr. Dharmendra Kumar sir is presently working as an assistant professor at Department of Statistics and Demography, National Institute of Health and Family Welfare, New Delhi. He is an assistant nodal officer of Learning Management Information System, a digital learning initiative of Ministry of Health and Family Welfare, and former nodal officer of the Center for Health Informatics, Ministry of Health and Family Welfare, Government of India. He is the Fellow of Royal Statistical Society, London, UK, and elected member of International Statistical Institute, Netherlands. His fields of specialization are artificial intelligence, machine learning, health informatics, digital health, and sampling theory. He has 40 research publications in various journals of national and international repute. Sir has been the editor of 10 books and contributed 20 chapters to various books. Dr. Yadav sir is the author of 2 popular books on digital health in India, evolution of health informatics, and artificial intelligence and machine learning in healthcare. Dr. Yadav is member of many professional bodies, including Indian Society for Medical Statistics, Biostatistics Consortium, International Biometric Society, and Indian Statistical Institute, Kolkata. He is also associated with research projects of Ministry of Health and Family Welfare, ICMR, and UNESCO. Dr. Yadav received Research Excellence Award 2020 by Institute of Scholars, Bangalore. Excellent Presentation Award at a 5M International Conference 2021 at Waseda University, Japan. And Best Paper Award at International Conference 2022 by American Institute of Management and Technology and University of Maryland, Eastern Shore, USA. Now, I would like to invite sir kindly lead today's session. Please, sir, welcome, sir.
Thank you, Amit, for your nice introduction. So, I hope all the participants have some work on SPSS, what we have delivered yesterday. So, just give me 1 minute. So, my voice is
Yes.
okay.
Yes. Perfect, sir.
So, what we have uh, discussed yesterday. That was how you can do the descriptive statistics using SPSS. So today I will give a brief, introduction that how this some parametric test can be used, how we can do the, testing of hypothesis by using parametric test, using like t-test for the single sample, two samples t-test, and pair t-test and ANOVA test. How these tests can be performed using SPSS. So I hope some of participants have downloaded the trial version. So I'm just giving a brief, outline, because as you know that there are basic four parametric tests which are generally used. Number one is t-test, but t-test has two things. Number one, for the single sample, and second is t-test for the two samples, independent samples. We want to compare the means of two samples, then t-test can be used. And there is a pair t-test. Okay, so what is the difference between this pair t-test and the other two types of test? Single sample means if you are comparing only single mean of a particular population mean with the sample mean, single sample mean, then t-test can be used. And if you want to compare the means equality of two means or two different samples, independent samples, then t-test can be used. And the third one is pair t-test. So pair t-test is used when we are collecting the observation on the same object. Okay, suppose for example, if we want to know the, effect of any drug, on a sleeping drug, on the patient. Okay, though, so if you want to check whether this drug is effective or not, then how you will check? You will take the observations before giving the drug and after giving the drug. You will check number of sleeping hours before giving the drug and after giving the drug. Then we are collecting the observation two times on the same object, same subject. So in that case we use the pair t-test. It means you want to check whether there is a significant difference between the mean or not, but you are collecting the observation on the same subject before and after. So in that case we use the pair t-test. Then there is a one parametric test that is called ANOVA, analysis of variance. Okay, it means if you want to test the equality of means more than two. So for the single sample, for the two independent samples, we go for the t-test. And if we want to compare the equality of means which are which having the more than two samples, then we go for the analysis of variance, ANOVA. So these four tests are parametric tests. So today we will talk about this parametric test, how you can perform the analysis using the SPSS, right? So I'm just sharing the screen. So my screen is visible.
Yes, sir, visible now.
Okay, so this is the first case of one sample t-test. Okay, suppose we have given, okay, and we have one sample mean, and now we want to test whether this is uh, given mean is equal to the sample mean or not. Okay, so for example, there is another example. You can say that if we are taking the observation on a single sample only, okay, and this sample is a group of participants who are attending this conference or this workshop. This is the whole group. Okay, and from the previous study I have information that the average height of these participants is 150 centimeter. So this is our mean value. This is called population mean. It is already given to us from the previous study. Now we want to test whether this information that the mean average mean height of these participants is 150 centimeter, and we want to test it with the sample mean, and the sample mean will come from collecting the information from this group of people. Okay, so this is a case of one sample t-test, because here we have one sample only, and that is a sample of all the participants, and there is a previous information is given that the mean height of these participants is 150 centimeter. Now we have to check whether this given information of mean height is or not with the sample mean, right? So this is the case of single sample t-test. So in our case, we have a company ABC which launched a new brand of air conditioner for its customers and claims that under normal circumstances, the average life of air conditioner is 5,000. Okay, so this is a given information which is already given that the average life of this air conditioner is 5,000 days, right? So it is given from our previous studies or previous research. So it is our population mean which is given to us. Then a retailer wants to test these claims and has taken a random sample of 10 air conditioners. So there is a sample of 10 air conditioners, and this retailer want to test whether this claim of 5,000 days is true or not. Now the retailer tests the life of the air conditioner under the normal circumstances. Okay, so this is the observations on the 10 air conditioner, and we want to test whether the average life of air conditioner is 5,000 days or not, whether this claim is true or not, right? So this is the case of single sample t test, because here is only one sample, and one this sample has 10 observations on 10 air conditioners, and the one population mean is given to us, that is 5,000 days, right? Now this is the air conditioners. One, number of days is 4,600. Two, so this is our data, right? Now number of days this is the numeric variable, this is continuous. So this is our, now we will enter this data into SPSS and perform the single t-test, right? So this is our data which I have already filled it, that this is the one variable air conditioner, air condition, and it is a numeric data because 1 2 3 10, right? And this is the scale measure. Then the another variable is days, right? And it is numeric. So these two variables are there. And what is the data? This is our data, 1 to 10. These 10 air conditioners are there, and these are the number of days, right? Now we will perform the single sample t-test. Okay. So what we do, we go to the analyze, then can anybody tell me? You can write in the chat box. Okay, no problem. So we go to the analyze, then compare means, because here we are comparing, and then we perform the one sample t-test. So one sample t-test we perform to the test variable, that is days. Then options, we will not 95% of the this is already given. Then test value. Test value is what is the mean value, and it is already given that 5,000 days. Right? So this is our output. So this is our mean value 4880. Standard deviation is given. And then okay. So this is our t value. Degree of freedom will be 9. P value is 0.3113. Okay. So let's check our results. This is the values. This is the value of t. Degree of freedom is 9. Significant. It means this is the value of p value. This is the p value. And this is 0.311. Right? So our null hypothesis, what will be the null hypothesis? How we will check the, how we will formulate the null and alternate hypothesis in t-test, single sample t-test. Can anybody tell me what is the null hypothesis here? Life of air conditioner is less than 5,000? No. Always remember that null hypothesis is the hypothesis of no difference. Okay. So hypothesis, there is a no difference between the observed value and the given value. It means both are same. Yes, Dr. Ramkrishna, you are right. It means the average life of air conditioner is 5,000. An alternate will be, it is not equal to 5,000. It may be greater or it may be lesser. Right? So, please always remember that null hypothesis is always hypothesis of no difference. It means what we are assuming and what is given both has no difference. It means there is a no difference what we are testing and what is observing. Right? It means the average, we have to test the average age of life, life of air conditioner is 5,000. So our null hypothesis is that yes, the average life is 5,000. It means there is no difference between the given value and the observed value. So this, in this way you will make the null hypothesis. So alternate will be according to your problem, what you want to check. So now let's check what is the our p value. So our p value is 0.311. What? So this is, I have told you yesterday that if p value is greater than 0.05, then our hypothesis will be accepted. Null hypothesis will be accepted. Right? It means our null hypothesis will be accepted because it is 0.311. It is greater than 0.05. It means there is a no difference. It means the average life of air conditioner is 5,000. It is what is claiming is right. It means this is the reporting of your result, that we do not reject the null hypothesis that sample mean is equal to the 5,000 days and conclude that population mean is 5,000 and sample mean is 488. It means there is no significant difference. It means retailer claims right. It means what the retailer is claiming is right. And the mean is 488. This is the sample mean. And the population mean was 5,000. This is called test value. Right? So we have one sample, we have a test value that is already given, that is population mean, and we will apply the one sample t-test by using the analyze, then compare means, then one sample t-test, right? In one sample t-test, we want to test number of days, then we have test value, and what is the test value? It is given in your problem, given in your question. Through this is population mean, what is given to you. So we will put this value here, test value, then click OK. Then these results will come. And now we will check one sample t-test, what is the mean. And this is the sample mean, 4880, right? Standard deviation. And one sample t-test, this is our population mean. And now we will check the significant. Significant means whether what is the value of p value. So if p value is greater than 0.05 or less than 0. The retailer is claim is right. So in any problem in this single sample t-test, please let me know. Any issue or any outcome, you can tell me. So I think we can go for the second t-test. This is the single sample test. Then another problem is we have two sample t-test, right? It means we have two samples. It was a case of one sample. Similarly, there is a case of two sample also. So with my screen is visible or not?
Yes, sir. Visible, sir. Proper.
Okay. Okay then. So I'm taking the another case, that is a case of two sample, independent sample. Okay. So this is the another case. It is visible.
Yes, sir. Visible, sir.
So this is the case of second case, that is the case of two samples, right? It means we have two independent samples. Okay, for example, suppose I am interested in two samples. Suppose in our participants, one group is male and another sample is females. Okay, this is a two group, two samples, independent sample, and we want to test whether the average height of female is equal to 145 centimeter and male is 155 centimeter. So here are interested in two samples. One is male and another female, and we have two population means, and with the help of these two samples, we want to test whether these two population means are equal to the two sample mean, right? So this is a case of two sample, two independent sample t-test. Okay, so here we have example to know whether the salary of male faculty members in a private institution is equal to the salary of female. So here we have two groups, two independent sample. One sample is from male faculty members, another is female faculty members. But and this number of samples, or you can say that observations, may be same or may be different. It is not necessary that both the group have same observations. It may be same or it may be different, right? So these 20 male and 20 female may be same or may be different. Suppose there are 20 male and 18 female, it may be. So, but here in our case, we have equal number of faculty members. Now, we want to check, is there any significant difference between the salary or not? So here we have two variables. One is gender, and this gender is one gender is male, another is female, right? So what I have told you yesterday, that gender, this is a labeling. You are labeling that what is your gender for your understanding. And now we are putting the values, we are giving the values of according to the gender. That one is used for the male and two is used for the female. Okay. So in this way you can uh, put your data for your coding, male and female, because we have two independent group, male and female. One is labeling as male and second is female, right? And it is a nominal measure, right? Male or female. Then another variable is salary. So salary of teachers, it is a scale variable. So this is there are two variables. Gender, we have two groups, male and females, and we want to test whether the average salary of both groups is same or not. Then we have data. One, it means male. So we have 20 males, one, and their respective salary, and the another there are 20 females and their salary, right? This is our data for two independent samples. Now we want to test whether whether the salary of both the group is same or not. So what will be null hypothesis here? Please tell me. Because before doing analysis, because you must know what is will be the null hypothesis, because software will not give you the null hypothesis and alternate hypothesis. You have to create the null and alternate hypothesis by your own self. So what will be null hypothesis here? Please tell me. Equal, yes. Salary of both group is same. There is no difference between the average salary of male and female faculties. Good. So good. So it means we have to test it whether there is a significant difference. An alternate hypothesis will be yes, there is a significant difference between both the groups. Okay. So now we have data, we have t-test, and we have null and alternate hypothesis. Now we want to apply the t-test for two independent samples. Let's check. So we have this group. This is our. Now we go for the analyze, then compare means, then we have independent samples t-test, right? One sample t-test, independent sample t-test, pair sample, and one-way ANOVA. These four parametric tests are used for testing of means. So here, this is our case of independent sample t-test. So what is our test variable? What we want to test? Gender or salary? Tell me. What we want to test? Salary, yes. So we are interested into the salary. So our test variable is salary of teachers. And what is the grouping variable? Group means which type of group? Male and female, right? So define groups. Group 1 is your 1 and second group is 2. Then click on OK. So with this, we have this output. So group statistics, male and female, 2020. Great. So what is the salary of male teachers is 49,900. Okay. This is our sample mean. And what is the female group? 39,400. Okay. So this is our sample value. Now we will check whether it is significantly different or not. Significant value is 0.435. This is our significant. So our significant value is 2 tilde 0.00. It means what? Whether it is, what is the value of P? It is very less than 0.05. Okay. So how you will interpret? So what is your result? What is the P value here? 0.000. It means it is very less than 0.05. it means your hypothesis will be rejected. Okay? It means there is a significant difference between both the groups because your null hypothesis is rejected. Because this is 49,900 and this is 39,400. There is a difference and our p value is 0.000. So therefore our null hypothesis will be rejected. It means if it is rejected, it means there is a significant difference between the average salary of male and female population, female, faculty members. And here you can see, you can also see that the male salary is 49,900 and female is 39,000. So there is a difference, significant difference. And it is also here from 0.00. So in this way, you can perform the any doubt in this independent sample t test. Please let me know. So null hypothesis is rejected. Yes, there is a significant difference in the salary. Good. So this is the second t-test. Now we are going for the paired sample t-test. It means we are taking observations on the same subject two times. So we have the another t-test. This is our training data because when you will go for t-tests like FDP or training or anything, then we will check is there any significant change in your knowledge or in your skill after attending that workshop or attending any development program. So for that, we apply the pair t-test. Okay, suppose you are attending this workshop from last 3 months and you want to check whether this FDP or workshop program is significant, is useful for you or not. So how you will check? You will check the knowledge before attending this event and knowledge after attending this event. Okay, then we will check is there any significant difference before attending this event and significant difference in the knowledge, domain knowledge of statistics before attending this workshop and after attending this workshop. Then only you can check or identify whether this program or workshop is useful for you or not. Okay. So similarly, ABC University arranged a special faculty development program for the one segment of its teachers, right? The university wants to measure the change in the attitude of its teachers after the FDP. So for this purpose, it has used a well-designed questionnaire which consists of 10 questions on 1 to 5 rating scale. 1 is strongly disagree, 5 is strongly agree. The university selected a random sample of 20 teachers. Okay. Then we will check whether there is significant difference or not. So we have a data of paired. So it is taking some time. Okay, so this is our data. Before we have two variables, before and after. My screen is visible, Amit?
Yes, sir. Visible, sir.
Okay, so this SPSS window is visible.
Yes, sir. Yes, sir. Visible, sir.
Okay, okay. So we have two variables, before and after. It is a numeric value. So before faculty development program, this is our scale variable, and there is another variable after faculty development program. Okay, then we have observations. Some these are some values on the scale we have converted. 22, 26. This is the before attending the FDP, and this is after attending. Now we will check. We have to test whether this FDP is significant or not. This program was significant or not. Is there any significant difference between the domain knowledge or any skill after attending this workshop? So, what will be the null hypothesis here? Please tell me. So, what will be the null hypothesis? No change, no difference. Good. It means there is no significant change in the knowledge or any skill before and after attending this workshop. Right. So in this way, you will make the null hypothesis. So our hypothesis will be there is no significant difference before and after attending this FTP. Now we will check, and alternate will be yes. It means your knowledge is increased after attending this workshop. Okay. So we will go for the pair t-test in this case. So analyze, then compare means, then paired sample t-test. Okay. So paired variables will be before and the second is after. Okay, then just click on OK. So pair t-test will give the result. So pair 1 before faculty development program, mean value is this 24 something, and after attending 33. This is the mean value, this is the standard deviation, right? And the correlation between before and after attending this program is correlation is 0.253 and 0.283. This is a significant value. It means now the ultimate thing for your analysis is this table, paired sample t-test. Okay, so you will always make your decision on the basis of this table only, whether your hypothesis is rejected or not. So you will decide on this basis of this table. So now let's check mean, standard deviation, standard error, this one, upper t-test, degree of freedom, and this final significant, right? So this is a value of 0.000. It means it is very less than 0.05. The value of 0.000, it is considered as less than 0.05. So what it means? What null hypothesis will be rejected, right? So rejected means yes, there is a significant change with the help of this because here you can also check the mean before attending was 24 something and after attending was 33. Okay, it means there is a improvement in the knowledge. Okay, suppose the knowledge, mean knowledge was 24 before attending the workshop, attending FDP, and after attending it was 33. It means there is a improvement. That's why it is also reflected in the significance also. It means your value is 0.000. It means it is less than 0.05. Okay, it means yes, your hypothesis is rejected. It means what was null hypothesis? That there is a no significant change. But since it is rejected, it means there is a change. It means there is a significant improvement after attending the FDP, Faculty Development Program. So in this way, you can apply the pair T test, right? So any doubt for this pair T test, please let me know. Okay, so how degree of freedom is decided? Okay, actually the degree of freedom is nothing, only the number of independent observations. So whenever you go for different, T test, so suppose there are single sample T test, total degree of freedom will be total number of observations minus 1. Okay, then suppose there are two samples, then degree of freedom will be n1 plus n2 minus 2 degree of freedom. Okay, suppose n1 in the first group, n2 in the second group, then you just sum n1 plus n2 minus 2, because it will reduce to two observations into that. Then pair T test, degree of freedom is 19. It means total observations minus 1. Okay, so paired, T degree of freedom is described or defined as the total number of observations minus number of restrictions imposed on them. Okay, so this is the number of independent observations. Generally, one restriction is there. That's why degree of freedom reduced to 1. But this is for the one case. So it can vary from one test unit to another test. So any doubt for this pair T test? Okay, so now we can move for our next parametric test. That is your, ANOVA, analysis of variance. So when this analysis of variance is analysis of variance, suppose one sample t-test, we use t-test. For two independent sample, you use t-test. For paired, repeated, like paired sample, you use the t-test, right? But suppose we have more than two groups for testing of means. Okay, suppose one group in your this there is a one group from Ayurveda students, one group is allopathic, and some may be homeopathy. So there are three groups, and we want to test whether the average mean knowledge of all these three groups are same or not. So this is the testing of three groups, independent sample groups, right? So in this case, whenever there are more than two groups, then for testing of mean, we use ANOVA test, analysis of variance, right? So for single sample of mean, we go for the t-test. For two independent sample, we go for t-test. But for more than two samples, independent sample, we go for the ANOVA, analysis of variance. So now we have our data of analysis of variance, ANOVA. So an experiment in which a major department store chain wanted to examine the effect of level in store promotion. The experimenter wants to know the impact of in-store promotion on sales. So in-store promotion was varied at three levels. Okay, high promotion, medium promotion, low promotion. There are three categories or three groups, independent sources. Now we want to test whether the mean of all these three groups is same or not. So what we do? Let's check for the data. What the data we have for this analysis of variance. Okay, so we have variables promotion and sale. Okay, so promotions have three levels: high promotion, medium promotion, and low promotion. These are three groups. Okay, and we want to check whether the mean of these three groups is same or not. So this is the nominal. Similarly, there is a sale, that the average sale and promotion. Okay, we want to check whether the sale of in all these three groups is same or not. Then we check the data. This is one or two. One is high promotion, medium promotion, and three is promotion. Something like that. We have three groups here. Just like in first case, we had two independent sample. One was male and another was female. There were two groups. But here we have three groups: high promotion, medium promotion, and low promotion. So we have more than two groups. So for this, we go for the ANOVA. So now this is the data. Now we apply the analyze, compare means, then one way ANOVA, right? So we have independent per day sale. This is your dependent list. Then what is your factor? These are the factors. Then click OK. Okay, let me check. Please tell me what will be the null and alternate hypothesis here. So what will be the null hypothesis? That the sale of in all these three groups are same. There is no significant difference between these three groups. It will be a null hypothesis. And alternate will be yes, at least in between two group, the sale is different, right? So what you are getting from here? Your significant value is 0.000. So what is the meaning of this? What is the p value here? So your p value will be lesser than 0.05. It means you are rejecting your null hypothesis. And what was null hypothesis? That there is no significant difference between the average sale between these three groups. It means there is a significant difference between these three groups, right? So in this way, you can apply the analysis of variance test, ANOVA test. Okay, so I have told you these four tests: t-test for single sample, t-test for two independent samples, pair t-test, okay, and then ANOVA, analysis of variance, right? So in any doubt in these four tests, please let me know. So Amit, it was about my today's session. So any no doubt from the participants, you can ask me.
Thank you so much for very informative and knowledgeable session, sir. And I request to participant then please write your query in the chat box or simply raise your hand.
Or any doubt from your any statistics session, I will be more than happy to give my inputs.
Thank you so much, sir. Thank you so much.
Not only for these three, this one.
Yes, thank you so much.
You can ask any query, so I will try to give the answer for any statistics. Like, yes, there is someone is raising the hand.
Please unmute yourself.
Yes, good evening, sir.
Yeah, very good evening.
Thank you so much, sir, for making the thing so easy. I mean, I was not sure that on online I'll get any information about SPSS. Will I be able to understand anything?
Hello.
But whatever I was thinking, hello, sir, can you hear me?
Yes, 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 please, please.
Yes, yes. Sir, but the way you have taken our classes for SPSS, sir, we have understood. I mean, most of the things we have understood. So thank you so much, sir. Uh,
Thank
so
you,
just
madam.
one
So,
doubt.
yes, yes, please.
Yes, sir. Just one doubt, sir. Like now, as you have explained us null hypothesis and alternative hypothesis, I mean things have
Mhm.
become very clear. So here only I would like to ask you, can you please just tell us about alpha and beta error? The way
Okay.
now this clarity of hypothesis has come, I just want all of us to have clarity of alpha and beta error because the more we study the definitions in books, no, different books, we tend to get confused. I do not know whether
No,
it is with everyone or it is with me. There
no,
is
no.
some sort of confusion.
You just want to know what is alpha and beta?
Yes, sir. What is alpha and beta error?
Okay. So actually, you all know this is the process. You that it is a part of someone asked about this. Chi-square. So chi-square is comes under non-parametric test. Okay. If you suppose your data is not fulfilling normality assumption, then we go for the non-parametric test, and chi-square is one of them. Right. So yes, madam. So actually, this whole inferential part, this is the called decision making process. Okay, this is a decision taking process. Here you are taking decision. Okay, this any hypothesis will be accepted or rejected. Okay, you are taking the decision, right? So your decision maybe you can, in the real life also, uh, at the time of taking any decision, you can commit the mistakes. Okay, and there are two types of mistakes you can commit. Either you can reject the right person, either you can reject the right person, or you can select the wrong person. So in this way you can commit two types of error. So the same thing happened with the this inferential statistics part also. Suppose your hypothesis is right, null hypothesis is right, what you have assumed that there is no significant difference, and yes, in real life also there is no difference, but you are rejecting that. It means you are committing of error of rejecting the hypothesis when it was right. So that
Yes,
comes
sir.
that is called type 1 error, and its probability of committing type 1 error is called alpha, right? So alpha is not type 1 error, this is the probability of type 1 error.
Right.
Similarly, suppose your null hypothesis was wrong. It means you are saying that there is no significant difference, but there was a significant difference, but you are accepting the null hypothesis. It means you
Right,
are
sir.
accepting the wrong thing. wrong null hypothesis. So that is called type 2 error, and its probability is called beta, right?
Okay. Yes,
Suppose
sir.
any, I'm just giving a, uh, this lighter mode. Suppose any relation or any, person or any, कोई कहते हैं ना कि रिश्ता है आपकी शादी के लिए, सपोज, ओके, अब आपको चूज करना है कि इसको एक्सेप्ट किया जाए या रिजेक्ट किया जाए. सपोज आपने एक अच्छा पढ़ा था, उसको आपने रिजेक्ट कर दिया. इट मीन्स यू आर रिजेक्टिंग द राइट, सो यू आर कमिटिंग वन एरर. और कोई बंदा सही नहीं था, उसको आप कर लिया. It means you are accepting the wrong person. So this is called type.
Right, sir. Got it. So rejection of null hypothesis
When it
even
when
if
when
it
it
is
was
correct.
when it is true.
Yes. That is our
That is type 1
type
error.
1. Type 1.
Yes.
Okay, sir.
Yes.
Got
Yes.
it, sir. Thank you, sir. Thank you
And
so
this
much.
probability of type 1 error, that is also that is also called level of significance also.
P value.
Okay, sir. P value.
Okay. Alpha value or p value.
Great, sir. Thank you, sir.
So I'm just adding one thing also here also, because I'm from statistics, a statistician. So what is the concept of p-value? Because many of you are using this p-value, as I have also mentioned many times during this my 3 day session, that what is the p-value? Because p-value is something different.
Standard deviation.
What?
When the area falls under 2 standard deviation.
Okay, but what is the reason behind this p-value? Why we are not taking alpha?
To get the significance level.
But level of significance is called alpha.
Acceptance level means
using this
whatever
p-value?
whatever this our values falls under this particular zone will be accepted, and this is called alpha.
Okay, this is, so the p-value is generally used for the probability value. This is the probability. P-value is nothing, only the probability value. And the probability of what? Probability of accepting the null hypothesis under the assumption that it is true. Okay? Means this is the probability of accepting the null hypothesis. If you are accepting the right thing, and the probability of acceptance, that is denoted by p-value. So as much as p-value will be higher, the chances of accepting the null hypothesis will be higher, because this p-value lies between, probability lies between 0 and 1. So there are half cases, half percent, 50% cases, 50% chances of acceptance and 50% rejection. So as much as this is close to 1, that is more than 50% chances, that's why it is called the p-value. If it is greater than 0.05, then we will, accept the null hypothesis. This is the concept of p-value. So it means this is the probability of acceptance of null hypothesis under the assumption that it is true. You are accepting the right null hypothesis. Any other doubt?
Sir, can you please explain me the exact concept of this chi-square test? Actually,
chi-square. It's not chi-square. It's a chi-square.
No, for remembrance, I just
No problem. No, it happens many. It happens many
college.
times with non-statistics person. So this is a chi-square. It's a French term. So actually, this is a someone is writing my name, but my name is Dharmendra. DHAR. So okay, this chi-square test comes under the non-parametric test, right?
Yeah, that.
And this is used for different purpose. Number one, for testing of the association of attributes. Okay, suppose you want to know the association between two variables, and these variables are qualitative in nature or categorical.
Okay.
Categorical. Okay. Categorical means we have two categories. Suppose we want to check whether there is a relationship or association between the lung cancer and smoking. Okay. So there are two variables or two categories of variables, and we want to check is there association between these two variables, and these variables are categorical. Either you are smoking or not smoking, two categories. Either lung cancer is there or not lung cancer is there. So in such cases, we go for the chi test, right? So this is the
Okay.
one application of chi-square test to measure to test association between two attributes. And these
Then,
attributes,
then how it differs from correlation?
no, correlation is this variable, only variables. Correlation gives the relationship only, whether is the relationship exist or not, positive relation or positive relation. Okay, but the nature of variable I'm just taking. In suppose your variables are categorical, then correlation coefficient give not not able to give the real picture. So in that case, we go for this chi-square. Okay,
Okay, sir. Thanks.
please. Okay. So anything else? So can I know the Amit, what is the nature of participants? What is the target group? These are from Ayurveda background
Yes, sir.
or mixed?
All from Ayurveda background, mostly 80% are from Ayurveda backgrounds. And this program is totally customized and hosted by our Joint State Training Center of Rajasthan and collaboration with CCRS, Institute of Applied Statics, jointly organized with
Hmm.
National Institute of Ayurveda, Jaipur,
Okay.
collaboration with
Okay. Great.
CCRS. And there are
Hmm.
600 plus participants are with us from Ayurveda background, mostly across
Hmm.
India.
Great, great. Because you all are doing very, good thing. Because these are our, this, because statistics must be for the, very quality research.
Yes, yes.
Quality, quality, quality.
For that we are starting this program, Master's Chartered Research and Development Scheme for Ayurveda
Hmm.
professionals only, and this is our first program. And I'm very
Hmm.
happy that all participants are actively participated in this program, and this will enhance our credibility. Then we can move towards new programs like for SPSS and are separately different programs for Ayurveda professionals to aware.
Yes, yes. Yes, but the basic concepts of statistics will give the improve the quality of research, what
Yes,
research they are doing for the statistical analysis. So that is a nice initiative.
yes, definitely, sir. Uh,
So I think we can wind up now because if the participants don't have any further queries,
yes, sir.
you
Yes,
can. If the
yes, sir.
participants have
Thank
any
you.
further query, you can contact to institute
Yes,
organizers and they will forward it to me.
definitely, sir. Definitely, sir. Thank you so much, sir. Very heartily thanks our respected guest speaker of the session, that means Dr. Dharmendra Kumar Yadav, sir, who kept the participant engaged by a very interactive, very informative session and a very interactive query round. Now, on the behalf of Institute of Applied Statistics, we convey our sincere thanks to all the participants for their active participation in all the sessions during this program. Now, tomorrow and the day after tomorrow, there is an assessment test, test 5 and test 6, depending upon these all sessions in the month of March. The test will be start from 6 p.m. tomorrow, and there is a time to complete the test day after tomorrow till 5 p.m. Now, one test will start tomorrow at 6 p.m. and another assessment 6 will start the day after tomorrow at 6 p.m. in our Statistico Android app. And the participants who are using iOS and Apple, for that we provide a link, a browser link to attend that test. And as all participants know that these all recorded session and PPTs will be available on our Statistico app, and access will be provided for a year. Throughout year, you can access all lectures, all recorded lectures of the session. And for validatory session of this program, we will soon send you the notification regarding them through our WhatsApp groups. After that, we provide the certifications. As soon as we cover the validatory session, we provide the e-certification. If there is any query, then we are available tomorrow at 5 p.m. to 5:30 p.m. Just online session to connect with our participants if there is any query regarding accessing of Statistico app, any issues, any technical deficiencies to access the study material in the app, or any difficulties to attempt the assessment test. So I will be available tomorrow at 5 p.m. to 5:30 p.m. Please connect at that time. I will send the link in the WhatsApp group regarding that. And this is the end of today's session. Thank you very much, sir, for delivering a nice and
Thank you.
knowledgeable
Thank you.
lectures.
Thank you. Thank you,
Last
Amit,
week's-
for giving me this opportunity, and I will be more than happy to see you all of again. So thank you, participants, for patiently listening. So thank you, organizers, for giving me this opportunity. Thank you. Thank you all.
Thank you very much.
Thank
It's
you.
an
Thank
honor,
you.
honor for us, sir, for your presence. And
Thank you.
I again thankful to all participants who are actively involved in during the whole program, like Dr. Harini, Dr. Asay, Dr. Anil sir, Dr. Sarai Kore, many participants who are joining the whole session throughout the session. They are available and participate actively. I'm really appreciate for that. Thank you. Thank you so much. Tomorrow session will start at 5 p.m., 5:30 p.m. There is no any query round. This is for sharing your feedbacks for any technical differences regarding to accessing the course. And that's it. Thank you so much. This is the end of today's session.